Now, we will see the output characteristics of common emitter configuration, but before that we have to see the relationship between output current IC versus the input current IB. That means, what is the relationship between IC and IB, because in case of the previous case, that is common base configuration, we have seen the equation, that is IC is equals to alpha IE plus ICBO. That is, depending upon the input current IE, how the IC will vary, we know that equation, and we know another equation, the important equation, that is IE equals to IC plus IE, that is emitter current is equals to base current plus collector current. And now we have to derive how the depending upon the input current, that is base current IB, the output current IC will change. So, for that we have replaced IE by IC plus IB. So, if we replace IE by IC plus IB, then in the next line if we take common IC, then it will be 1 minus alpha is equals to alpha IB plus ICBO. Like this way we will get IC is equals to alpha by 1 minus alpha IB plus 1 by 1 minus alpha ICBO. Now, if we consider this term, that is alpha by 1 minus alpha is beta, then we can conclude that IC is equals to beta IB plus beta plus 1 ICBO, because beta plus 1 is equals to 1 by alpha. And this one is the important relationship between these two amplification factor, that is alpha and beta. Now, if we consider this beta plus 1 ICBO is equals to ICEO, that is reverse saturation current in case of common emitter configuration, the amount is very negligible, because the value of beta will lie from 50 to 400. So, obviously, this part will be larger, much more larger than this term. So, we can ignore this term, and so we can write IC is equals to beta IB. So, the beta value is equals to IC divided by IE. So, we can see the beta is the current amplification factor in case of common emitter configuration. Now, in case of common emitter configuration, if we see the output characteristics, that is IC versus VCE, then the output waveform look like this. Why? Because of, see, if we study this equation, then if we ignore this IB, that is if IB value is 0, then obviously the IC kind is beta plus 1 ICBO or ICEO, which is defined by this. Now, when we increase the beta IB, because for a circuit beta is constant, so if we increase IB1, IB2, IB3 like this way, then depending upon the beta, the current will be increased and the amplification is more in case of this common emitter configuration. And there are also 3 regions. This one is say region A, region B and region C is there. See, this region B is called active region, where the amplification is done, and there is another 2 region, that is region A and region C, where region A is called saturation region and region C is called cutoff region. So, this is all about common emitter configuration of NPN transistor. Thank you.